Hi, in this lesson, we are looking at the properties of the states of matter. Generally, there are three main states of matter, which are solids, liquids, and gases. So we are going to look at their properties, and to help us to look at the properties, we are going to focus on these 8 items. So the first item we are going to look at, but let me be quick to add that by looking at these properties, we are also comparing or looking at the differences between the 3 states of matter. Let me also be quick to add that there is a 4th state of matter, which is a plasma state, and this lesson focuses on the 3 major states of matter. Now let's look at the first property, which is molecular arrangement. Now, in solids, the molecules are arranged very close to each other to form a compact structure. Remember that we said that in one of our previous lessons, we said that all matter contains very tiny particles, which could be atoms, molecules, or ions. And actually, it is the arrangement of these particles that gives the structure of the state of the matter. So in solids, the molecules are arranged very close to each other to form a very compact structure. Now, what about liquids? Now, relatively, the molecules of liquids are close to each other, but there are enough spaces between the molecules. Now, what about gases? For gases, the molecules are spread out. Right? So for gases, there exist very large distances between the molecules. Now let's look at the second property, which is the volume. Now, liquids or solids have fixed volume. Now, if you take a look at an exercise book, right? This exercise book has a fixed volume. How do we know this volume? We can know the volume by just multiplying the length and the breadth, right? Multiplying these two gives us the volume of the solid. What about an egg? The egg is spherical, and we can easily determine the volume of this sphere structure. So generally, all solids have fixed volume. What about liquids? Liquids have fixed volume. Let's say I have this container and I fetch 20 centimeters cube of water into this container. Now, when I transfer the water from this container, the same volume of water from this container to a very large bowl, the volume of water will still be 20 centimeters cube. Nothing will change. And because of that, liquids have fixed volume. What about gases? Gases have no fixed volume. For gases, they have no fixed volume. In fact, the volume of a gas at any point in time changes. In transferring a gas from one container to the other, you will not get the same volume because it is a gas. And it can leave the container into the surrounding, and so the volume will reduce. Now let's look at the third property, which is the shape, which is the shape. Now, solids have fixed shape. Now, once again, let's take a look at this exercise book. Now, you can see that this exercise book is rectangular. It's rectangular, all right? We can also take a look at a cube of sugar. The shape of this sugar is cube. It's cube, and so all solids have fixed shape. The shape of an egg is spherical, so it has a fixed shape. What about liquids? Liquids have no fixed shape. However, they assume or they take the shape of their containers. They take the shape of their containers. And this is what it means. Let's consider this container with water in it. If I transfer this container into another container that looks like this, the shape of the water in the first container will be different from the shape of water in the second container, in that the water in the second container will assume the shape of the second container. So for water, it has no fixed shape because it will take the shape of the container they find themselves in. Then for gases too have no fixed shape, and they also take the shape of their container. Now, let's look at the fourth property, which is density. Now, generally, density is given by the mass on volume. The ratio of mass on volume gives density. And for this relationship, what it means is that if the denominator is very small, the entire fraction will increase. And if the denominator is very high, the entire fraction will be small. Now, for solids, because the particles have been arranged to form a very compact structure, what it means is that the molecules, by reason of their arrangement, occupy a very small space. And a space occupied by an object is volume. And because the volume here is very small, density of solids is very high. Now, what about liquids? For liquids, the particles are a bit spread out. There are spaces between the particles, and so this makes the particles occupy a large space as compared to that of solids. And because they have large space, the volume is very high, and relatively they have high to medium density as compared to that of solids. What about gases? Gases have very low density because the particles are spread out, and this makes them occupy a very large space as compared to solids and liquids. And because of the very large space, volume is extremely high, and hence the density is very low. Let's look at the fifth property. Which is intermolecular force. Now, the various particles that come together to form either solids, liquids, or gases do so by means of an attraction that exists between them. This attraction that exists between the molecules is what we call the intermolecular force. if you take a look at solids, solids have their particles very close to each other because they have very strong intermolecular force of attraction. And so the particles are held strongly to each other. Because of that, all solids have very strong intermolecular force. Now, what about liquids? Liquids have spaces between the molecules, all right, as compared to that of solids. And because of the spaces between them, the intermolecular force of attraction between the particles is relatively strong as compared to that of solids. What about gases? For gases, because they are spread out, it tells us that the attraction between the individual molecules is very weak. It's very, very weak. So over here, we can say that we can draw a conclusion and say that the smaller, or let's say intermolecular force is inversely proportional to interdistance, or the spaces between the particles. So the smaller the spaces between the particles, the stronger the intermolecular force. Now let's look at intermolecular distance. Now, what is intermolecular distance? Intermolecular distance is simply the distance between the molecules that forms either solids, liquids, or gases. Now, for solids, they have small or no distance between the particles. So as we can see from the structure or the molecular arrangement, the distance between the particles is very small, or there is no distance at all. Then for solids, for liquids as compared to solids, they have wide intermolecular distance. What about gases? They are very spread out. And so the intermolecular distance as compared to liquids and gases is very, very large or very wide. Let's look at the seventh property, which is compressibility. Now, what is compressibility? Compressibility is the ability to change the position of a structure from a high position to a very low position. So if I'm able to reduce the position from here to the bottom here, it means that I've been able to compress the substance. Generally, because of no distance between the molecules of solids, it is difficult to compress solids. As a matter of fact, compressibility is directly proportional to intermolecular distance. Compressibility is directly proportional to intermolecular distance. So the smaller the intermolecular distance, the difficult it is to compress the structure. Because solids have smaller intermolecular distance, they are highly incompressible. What about liquids? For liquids, there is enough spaces between the molecules, and so it can easily be compressed. What about gases? Gases are highly compressible. Because of the very large distances between the individual molecules. That is why a large volume of a gas can be compressed into a very small container, because gases are highly compressible. Now, what about the flow? So the last property, the flow. Now, solids cannot flow. Solids cannot flow. They can't flow because they have strong, very strong intermolecular force and also very small intermolecular distance or no intermolecular distance. Generally, if the intermolecular force is very high, the ability to flow will be difficult. The ability to flow is difficult. Unlike solids, liquids and gases can flow. Liquids and gases can flow. So, we can easily pour water from a container. It is possible. Then, we can also make gases to flow by just connecting a tube. If a tube is connected to a gas cylinder containing gas, there can be a flow of the gas through the tube into wherever you want it to get to. And so liquids and gases can flow. And because the two can flow, they are collectively called fluids. So a fluid is simply a substance which can flow. But let me be quick to add that between liquids and gases, gases can flow more easily than liquids, because for gases, they have very weak intermolecular force, and so the molecules can easily flow or just be apart, unlike liquids. Thank you for watching this video. In our next lesson, we'll look at the transformation that can occur among these three states of matter.